Welcome back to Graphing Parabolas Part 2. This time we're going to look at how to find a vertex of a parabola in this form right here. But quick review, right? Parabolas either open up, like right here, or down. You can have two forms of an equation. You can have this form here, or this form here. So f of x equals ax squared plus bx plus c, or f of x equals ax minus h squared plus k. And the only thing, every parabola can be written in either the first form or the second form. Beyond that, the only thing the forms share that will always be the same is a. A will be the same for both. And a tells us a lot, right? If a is greater than 0, you're going to open up. If a is less than 0, you're going to open down. The absolute value of a tells us, is it narrower or wider? In general, if a is closer to 0, it's going to be a more wide parabola because the y value is growing slow, very slow. If a absolute value of a is large, usually bigger than 1, it's going to be very narrow because the y value is growing faster. So each time you try to do x value, it's going to go up or down much faster. So the vertex depends on, is the lowest point or the highest point. And again, domain will always be minus infinity plus infinity. And the range will depend on how you have the vertex. So like if it opens up, you go from your y coordinate to the infinity. Those are your y values. If it opens down, you start your y coordinate and you start small. So I start with small, so it's minus infinity. And you come up to y. So it should be like this. Okay, that's the quick review. Now, finding the vertex of parabola. In y equals ax squared plus bx plus c form. It uses a formula. If you're interested, I'll go through where the formula comes from. I'm not going to do it in this video. The x coordinate of the vertex is given by x equals minus b over 2a. There it is. That's all we need. All right, let's do an example. Let's graph g of x equals x squared plus 2x minus 3. So, first thing, in this case, we'll do, what is a? A is the number in front, right? So a is 1. Which is greater than 0, so open up. The absolute value of a is also 1. And we said last time, there's no change from base form of y equals x squared. All right, vertex. First thing I make note of, a is 1, b is 2, c is minus 3. So x equals minus b over 2a. So b is 2, so minus 2 over 2 times a, which is 1. minus 2 over 2. There's our x-coordinate. All right, how do you get y-coordinates? If I have an x value, I put it into the function. So y equals g of this value, and then I'm just going to use my function up here. So minus 1 squared, so right there. Plus 2 times minus 1 minus 3. So 1 minus 2 minus 3. Or 1 minus 5, minus 4. Or y equals minus 4. So your vertex is the ordered pair, minus 1, minus 4. And like before, once you have your vertex, you're going to make a table. Symmetry still applies. So let's make a table. And wait, I'll come back to that. We'll do domain range in a second, because I forgot to do that last time. Here's our table. The vertex will always go in the center. And then to do symmetry, I want to move equal distances on either side of the vertex. So 0 minus 2. 1 minus 3. And those should all have the same y values. So let's go back to our equation. There's our original equation there. Let's write it down here so we can see it. Okay, so it's going to be 1 squared plus 2 times 1 minus 3. 1 plus 2 minus 3. Well, that's 0. Because x is 1, it's the same distance from the vertex as minus 3. That's also a 0 value. Okay, and now this one. So I have 0 squared plus 2 times 0 minus 3. 0 plus 0 minus 3. There we are. There's our picture. Our graph for our picture. And then all right, so starting with the top and working down the table, I have 1, 0, 0 minus 3, 1 minus 4, minus 1 minus 4, minus 2, minus 3, and finally minus 3, 0. There's our picture. Again, let's look at domain range here. As we said earlier, let's go back and take a look real quick. Domain, because the parabola grows like this the whole time, it's always going left and right as it goes up or down. So it's everybody. That's why it's minus infinity to plus infinity. The range goes from the smallest y value to the biggest. So if you're opening up, you start with the y coordinate of your vertex and go to infinity. If you open down, you start at minus infinity, go up to the y coordinate of your vertex. So our domain, 0, no, minus infinity to positive infinity. Because I'm going all left and all right. The range, because we're opening up, our lowest value is right here at our vertex. We want the y coordinate, we want the x coordinate, we want the lowest value. So that's a y coordinate. So that's going to be right here at -4. And the y values keep growing as it spreads out. So it's going to -4 to infinity. Okay? Let's do another one. This graph, f of x equals -2x squared plus 8x -4. So in this case, a is -2. So we're going to open down. The absolute value of a is +2. And that's bigger than 1, so this is going to be more narrow. All right. Let's look at the vertex. Vertex needs to look at a, which is, we just said, -2, b, which is +8, c, which is -4. X equals -b divided by 2a. So -8 over 2 times -2. So that's -8 over -4. So +2. Oh, no, not y. Still not y. And y is you take this x value and you put it into your original function. So y is f of 2 again. Just going to pull this guy right down here. So -2 times 2 squared plus 8 times 2 -4. So -2 times 4 plus 16 -4. Well, you minus, that'll be -8 plus 12 or 4. So our vertex is our ordered pair 2, 4. And after that, it's just like I did before, like I said earlier. Make a table, use symmetry, and everything. So let's go ahead and, so we don't forget it, we'll rewrite the function right there, just so it's easy for us to look at. All right, make your table. Put my vertex here in the center. I'm going to use symmetry, so I'm going to move equal distance on each side. So I usually do distance on 1 on either side, distance of 2 on either side. So distance of 1 is 1 and 3. Distance of 2 would be 0, then 4. Which value should I use to find which values of x should I use? Should I use the 0 or the 4, the 1 or the 3 to find the y value? It actually doesn't matter at all. My advice is small numbers are usually easy to work with, so I would use 0 and 1 over 3 and 4 because it's smaller, less work on yourselves, but it actually doesn't really matter at all. So, all right, for 0, I have minus 2 times 0 squared plus 8 times 0 minus 4. So 0 plus 0 minus 4. So I mean, I have the point 0 minus 4 and the point minus 4. Sorry, plus 4 minus 4. And then we're going to do 1 and 3. 1's going to be easier, so minus 2 times 1 squared plus 8 times 1 minus 4. So minus 2 plus 8 minus 4. Or minus 6 plus 8 gives you positive 2. There we are. Now I can go ahead and draw our picture. One, two, three, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, we have 0 minus 4. Again, I'm starting from the top of the table and just working down. I have 1 plus 2. I have 2 plus 4. I have 3 plus 2. Finally, I have 4 minus 4. And when you're drawing a parabola, everything should be rounded. So the tip shouldn't be like a spear. It should be more round, kind of like a butter knife. Sometimes it's kind of hard to make a rounded tip. But there we go. All right. Domain. Well, parabolas, we said, always go far left, far right, so there's everybody, so minus infinity to plus infinity. The range, well, it goes from the smallest value to the largest value. So smallest values are way down here. So we'll go from minus infinity up to the highest value. The highest value is right here at the vertex. So the highest y value is this 4. So that's my domain range. Right, so that's how to find the vertex if you're in the f of x equals ax squared plus bx plus c form. Let me know if there's any questions.